All right. Hello and welcome, ladies and gentlemen, to today's lesson. We're going to be talking about some relations and functions. I'm coming to you live from Mr. Gumke's classroom. I guess not really live by the time you see it, but that's why this video is a little different, why I'm standing up, and I'm going to be doing it on the same whiteboard I'll be teaching you guys on tomorrow. So here we go. So today we're talking about relations and functions. And then later we'll talk about how to solve some functions. But first, we're going to talk about relations. So we need two things to have a relation in math. The first thing we need is we need an input, also known as an independent variable, which I'll explain a little more about the independent variable part in a moment. And then we need an output, or a dependent variable. All right, so looking at this simply first, before we talk about independent and dependent variables, we're just going to talk about input and output. So we need some kind of input, and then our relation will make it so that we have an output that we get. So an example of this in real life would be like how many hours you work and how much money you make. So say, and then this is how we denote, or this is how we mark relations. So let's say we're talking about hours worked and money made. So let's say that someone works 40 hours in a week and they make $11 an hour, which I think is minimum wage. I don't know. So they make $440 for working 40 hours in 1 week. And then we put another comma. There's a lot of commas in this, I know. So what if someone else who works 40 hours in a week makes $12 an hour? Well, they would make $480 in 1 week. And then, maybe you have someone who works a part-time job. They work 30 hours a week, and they make that minimum wage $11. So they make $330 a week. So this would be a relation, and we put all of our relations. It looks like an ordered pair. We put our relations into parentheses here, separated by a comma. This first number is always going to be our independent variable, or our input, and then the second one will always be our dependent variable, or our output. And the reason that is because, so now getting into the independent variables, the number of hours you work, in real life, your job, how many hours you work is dependent on what job you work, how much your boss likes you, et cetera, et cetera. But for this instance, we're just saying the number of hours you work is independent, or it's free, right? And then the amount of money that you make, your output, or your dependent variable, it's called that because the amount of money you make is dependent on how many hours you work. So just like we said, this person and this person here, they both make the same amount of money per hour. We said $11 per hour, but the person who works 40 hours makes more money because they worked more hours, which makes sense. So, so this is how we denote a relation. Again, input or independent variable, and then separated by a comma, and then we have our output, or our dependent variable. So then our whole relation, so we have all of our little baby relations in here, and they're also separated by commas. Our whole relation is marked by these squiggly brackets, square brackets, whatever, not square brackets. I like to call them squiggly brackets. We've done this a little bit in one of our other, I forget what lesson it was, but yeah, they're coming back. So this is how we would denote a relation. And so this relation, like we said, would be how many hours you work and how much money you make. Another example of a relation, sorry, my notes are on this side of the board. I should have done it over here. But another example of a relation would be how much time you spend studying and the grade you get. So maybe on a test. So we're starting a new relation. Okay, we're talking about a new relation. I'm going to do open parentheses. So I'm talking about one specific relation. So let's say someone studies for 1 hour, and they get, and this time we're going to use not numbers. I know it's math class, we should use numbers, but we're going to use letters because we use letter grades. So let's say someone studied 1 hour and they got an A. They're pretty good. They knew their stuff. Okay, and then so this next person, they studied 2 hours, and they also got an A. Look at that. So then our third person will say maybe they studied 1 hour, but maybe maybe they forgot something or they made a little mistake on the test, so they actually are going to get a B, unfortunately. And then we'll say we have another person here on the very end who studied for 0 hours, and just like what will happen to you if you study for 0 hours, they got an F. Okay, so this is our relation for amount of time studying to grade. So again, the grade that you get is dependent on how much you study, and we can see that in this relation, just because you study 1 hour does not guarantee that you get an A, but again, the grade that you get is dependent on how much time you studied, and this makes sense that if you have 2 people who each study for 1 hour, like I said, there could be small mistakes that were made. There could be, all kinds of things that go on. Maybe they just had a bad day and they get a B. So, dependent and independent variables do not always mean that when you get one, like say you studied 1 hour, that you will always get the same result. So like we can see here, these 2 people studied 1 hour and they got a different grade. Just like in our last example, 2 people work 40 hours a week, but because they make different amounts of money per hour, they get paid a different amount per week. So these are relations, okay? And so the thing that makes a relation, like we said, it has to have an input or an independent variable, and then it has to have an output or a dependent variable. And so these are both examples of relations. Now, if we're going to talk about functions, what functions really are is just a special type of relation, okay? And so the thing that makes a function special, that makes it different from these relations, is that for every, so I guess we'll back up one step, okay? Functions also need an input or an independent variable and an output or a dependent variable. And so the thing that makes functions different is that for every input, they have a unique output. And so what that means is, so functions, okay, here, let me erase some stuff. I hope you guys got these examples. If not, this is on YouTube. You could rewind, I promise. Okay, so we're gonna erase all this. We're talking about functions now. So I'm gonna say functions, okay? And then I'm just gonna put, just right here, for every input or independent variable, if that's what you prefer. I prefer input, it's a shorter word, less spelling, right? For every input, there is a unique, or one, okay, that means one, so, and we'll talk about that more in a second. There's a unique output, okay? So this is functions, they're just a special type of relation. So really when we talk about relations, they're like a big umbrella, okay, relation, umbrella, and functions fall under the relation, okay? They're just a little more specific of a relation. So yeah, for every input, there's a unique output. So what this means is if we were to go back to our examples of how many hours you work and how much money you make, okay? So our example, we had someone who worked 40 hours and they made $11 an hour, so they made $440 in a week. And then our next one, we had someone who worked 40 hours a week and they made $12 an hour, so they made $480. And then we had, the third person who worked 30 hours a week and they made $11, so we said this, okay? I guess I didn't need to erase that, but we're back here. So this is our example we did with the amount of hours you work and the amount of money that you make. So this would not be a function. The reason that is because, so our little kind of informal definition we have here, for every input, there's a unique output. So that means that for every input or every independent variable, so 40 and 40, okay, there should be one unique output. So what that means is that this person who made who worked 40 hours in this week, they made $440. Well, that means that if it's a function, okay, not always the relation, this is perfectly fine for a relation, but for a function, what we're saying is that anytime someone works 40 hours a week, they're gonna make $440. We can't have the same input, okay, the same input that both of them worked 40 hours a week. We cannot have the same input and different outputs. In a function, if you put in an input and you put in that same input, you will always get the same output, okay? I hope that kind of makes sense, okay? I don't have anyone to nod or not nod or look at me all tired like I will in class tomorrow, so for every input, there is a unique output. So this is not a function, okay? This is not good. We're gonna go X, not good, okay? But we can do an example of a function or of a relation that would be a function. That's a bad curly bracket or square bracket or squiggly bracket, whatever you want to call it. So this example that we did, this relation, was we were talking about multiple different people. We said this one person, we said like person one, okay, P1. We said that person one worked 40 hours a week. They made $11 an hour, so they got $440. We said that person two also works 40 hours a week, made $12 an hour, so they got $480. We said that person three worked 30 hours a week, made $11 an hour, they got $330. So what I'm going to do now, a real life example, okay, that was a relation, a real life example of how we could do a function with salary and wages is to look at one person altogether. So here we looked at 3 different people, and we looked at their 3 different wages and how much money they made, right? So what we're going to do now is we're just going to say, let's just look at person one. So this function of person one, or it will be a function, and we'll talk about why, right? So we said that person one made $11 an hour. Okay, so I'm just going to put, and we're going to go $11 an hour. Okay, we said person one makes $11 an hour. So if person one worked 0 hours in a week, say they went on vacation, right? They were sick for a week, okay? Then they would make $0, right? That makes sense. So our next one, let's say they worked 20 hours in 1 week. Maybe, they were gone for half the week or whatever. $11 an hour, that means that they would make $220 in that week. Let's say the next week, they worked 40 hours a week. It was a normal week, right? We know $440 because we already did here. Okay, and then I'm actually going to go down one more. We'll go down. Okay, so we're going from left to right, now we're right here. Okay, so let's say the following week, they worked 40 hours again. Well, because we're looking at one person, and because this is a function now that we're dealing with, because our inputs are the same, that means that our outputs also need to be the same. So they're going to be making $440 whenever they work 40 hours a week. And so we'll close that. And so this is a function because we know that for every unique input, okay, and I guess maybe I should have put that, for every unique, wow, I cannot spell. This is why I'm not an English person. So for every unique input, there is a unique output, okay? So our unique inputs here are 0, 20, and 40. We do have 2 40s, but we're talking about unique ones. And so what unique means is that, they're like one of a kind. How many one of a kind inputs do we have? Well, 0, 20, and 40. So for every unique input, there is a unique output. And so when we put in 0, we get 0. When we put in 20, we get 220. When we put in 40, we get 440. And when we put in 40 again, we still get 440. And so that's why this is a function. Now I'm going to do one more example of a function just kind of in this form, and then we'll learn how to solve some functions, okay? I'm going to go ahead and leave the little definition right there, okay? So I'm just going to do some numbers. I'm running out of real life examples that I can use, and plus the money one is most fun, especially, if we were to do one for Bill Gates, it'd be like he works 0 hours a week and makes $1 million or something, I don't know. Anyway, okay, so I'm just gonna make up a function in my head to show you guys. So we'll go like 0, you get a 4 out, 1, you get a 2 out, another 0, you should get a 4, and then we'll do this. Okay, so this, hopefully you're looking at this and you're thinking that this is a function. There might be some confusion because for our inputs 1 and 3, we have outputs of 2. And so it seems, okay, so if we look at our definition again, okay, for every unique input, there's a unique output. That's what makes a function a function. So if we look at our unique inputs, okay, we just have 3 of them. We have 0 that happens twice. We have this 1, okay, and then we have a 3. Those are our unique inputs. So for every unique input, 0, 1, and 3, there's a unique output. Okay, so what does that mean exactly? Well, I'm going to tell you what it doesn't mean, and hopefully that will help you understand what it does mean. So what that doesn't mean is that because when we put an input of 1, we get an output of 2, that does not mean that when we put an input of anything else, okay, it could be 3, it could be 4, 5, 6, whatever we want, just because we put in a different input does not mean that 2 is restricted, okay? It's not unique to the number 1. What it means is that if we have our list of unique inputs, okay, if we were to like draw, okay, their relation, or this is a function, okay, it's a relation, okay? So anytime we put a 0 into this function, we would get a 4 out. That's its unique output. Unique input, okay, unique input, unique output. Whenever we put in a 1 into this function, whatever it is, okay, we could name it f of x if we want. We're going to do a lot of that later, okay? Anytime we put a 1 into this function, we're going to get a 2. All right, and then now, anytime we put in a 3 into this function, we're also going to get a 2. So the thing that tends to trip people up when they think about functions and when they look at this definition is that they think unique output, they think that it means that there can only be one input that gives you 2. Okay, but what that really means is that just when I put in 1, its unique output, the only output that we will ever get when we put in 1 into this function is a 2. All right, and so same with the number 3. Anytime we put the number 3 into our function f of x here, we will get a 2 out, always. That's just, this function is that way. This is just the function that I've made up in my head. This is how it works. But I wanted to get this example so that you guys can see that unique input and unique output does not mean unique output in the sense that we can't have the same number twice. Okay, so now, if I were to, okay, never mind, we'll do it this way. Okay, so functions, how do they, I'll erase my little umbrella, how do they relate to algebra? How are they related to what we're doing in this class? Well, I'm glad you asked, imaginary student. So, I know you guys are probably going to dread this, but if I asked you guys to graph this, okay, you guys could do that, right? It would be like, here's our little graph. I know it's probably really small on there, but it's just an example, right? X, and then we'd say that this is 3 because it goes up 3. You guys can graph this, okay? You guys know how to do that. Well, with functions, all we're really doing is we're taking this y here, we're making it a function. F of x, okay, right here. F of x equal to x plus 3. So this is, and when you plug numbers into a function, just like when we plugged x's into our graph, so here's our function, okay? And here's our graph that we know how to work with. This is what we know, this is what we're hopefully learning right now. We know how to graph this. We know that if I put 0 in for x, then I'm going to get a 3 out for my y. The difference here is that this is a function, okay, and its function notation is the really fancy word for this f of x. And what that means is that, and the way I'm saying that, I'll write it out for you, f of x, what that really means is that this is a function of x, okay, f for function, okay. This is a function of x. The reason it's of x is because x is our independent variable. So going back to the very beginning, we talked about functions, or we talked about relations before that need independent and dependent variables. So whenever we make a function, okay, and it doesn't need to be an f, we use f most commonly because f and function, okay, we like to do that. It could be g of x, it could be h of x, those are really common ones as well. But for now, we're looking at this f of x, this function of x. We say that whatever it is of our independent variable. So if we were to change this up, if we were to talk about our real world example that we've been using with the number of hours that you work, okay, then maybe we could put h in there, okay? And then the way that would change our notation is that because h, we said that hours was our independent variable in that example, that means that we write this f of h now. F of, and then this would change as well, okay? F of h, function of h, because it is a function based on the independent variable of the number of hours you work, okay? So, with our function now, and I'll put this back to x's because I know you guys love those x's, okay? Yeah, so the way that we would solve these is the same as the way we would solve one of these, or the way that we did solve this earlier this year. So earlier this year, you guys would get a problem like this, and it would say solve, and then it would have this, and it would say when x equals 2, let's say, okay? And you guys, because you're really smart, you would know to take this 2 right, that x is equal to, and plug it right in right here. So we'd say y is equal to 2 plus 3, we'd get y is equal to 5. Well, when we solve a function, we're doing the exact same thing, okay? The only way that it's different is how it's going to be presented to you. So what we've done before is that we'd have, solve, okay, solve y equals x plus 3 when x equals 2. We plug in our 2, we get 5, okay? The way that it's going to be presented to you now is it will say solve, okay? And I'm going to leave this here so you guys can see it. It'll say solve, and then it'll be like this. Okay, now I'm going to explain this. So what we've done here, and what they're asking you to do when you see it like this, is they're saying solve this, okay, solve this function, and it's a function of x. We know it's of x because that's our variable right here. Solve this function of x when x, okay, x is equal to 2. And so they don't say it quite like they did before, but if you look at it, you can see where we had x before, now we have 2. So that's their way of telling you, we want you to solve this function when x is equal to 2, and then the process is just going to be the same as before. We're going to go f of 2, okay, and now we're going to plug a 2 in for anywhere there's an x, which just like we did with this one, is going to be 2 plus 3. So f of 2 is equal to 5. That's how you would solve a function. So I was liking the money example. We'll go ahead and do one of those real fast, or a couple of those maybe. So let's say earlier we were talking about the person, so we had person 1 who made $11 an hour. Well, how could you represent that in a function? How could you represent the amount of money someone makes based on the number of hours they work? Well, let's do this. We know that for every hour you work, you make $11. If you work 2 hours, you're going to make 2 times $11, right? If you work 3 hours, you're going to make 3 times $11, and so on and so forth. So if I had to make a function to represent this, I would do, okay, our f function of h, based on the number of hours, okay, is equal to 11 times, and I'm just going to leave it, or I guess I'll put this in parentheses. That looks kind of ugly. Sorry. What I'm trying to get at is it'll equal 11 times the number of hours that we work, right? So this is a function to represent, or this is the function that, this notation, okay, sorry, this is the notation that represents the function that we did earlier when we wrote it out with the squiggly brackets. So as you can see here, okay, so now if we said, how much money are you going to make when you work 40 hours in a week? Well, we know from earlier that if you work 40 hours in a week at $11 an hour, you're going to make $440. So the way that we would do that here, the way that we would solve it here, if we wanted to know, geez, if I work 40 hours, how much money am I going to make? Because we've made this function now. We would go, what is f of 40? How much money am I going to make when I work 40 hours? Well, it's equal to 11 times 40, which, like we said just a second ago, is $440. There you go. So let's see, how can we do this? No, that's the example I'm thinking of in my head is probably for another day, but yeah, there you guys go. So today we talked about relations. We talked about independent variables, dependent variables. Please go back and rewatch that if it was confusing to you. If you don't remember it right now, it was like 15 minutes ago or something. So please go back and watch that if you need. So we talked about relations, we talked about independent variables, we talked about dependent variables, we talked about functions, which is a fancy relation. We talked about some real world examples for both relations and functions. And then we talked a little bit about how to solve some functions. I know I only did a couple examples. I might throw up another video with more examples, we'll see. But for now, I'm gonna leave it at this, and then if you guys have questions, feel free to ask. Thanks for watching. Got more videos coming